Welcome to the wonderful world of right triangles. These special triangles have a secret. They love to host number triplets. But not just any numbers can join the party. Only special sets of 3 numbers get to play. These special guests are called Pythagorean Triplets. These triplets are like the best of friends. They fit together perfectly in a right triangle. Want to know their secret handshake? It's all about squaring their values and adding them up. Let's unlock the magic of these triplets. The Pythagorean theorem is like a recipe for right triangles. This theorem tells us how the sides of a right triangle are related. It says that in a right triangle, the square of the hypotenuse, the longest side, is equal to the sum of the squares of the other 2 sides. We can write this as an equation, a squared plus b squared equals sine c squared. In this equation, a and b are the lengths of the 2 shorter sides of the right triangle. C is the length of the hypotenuse. This formula is like a magic spell. It helps us find the missing side of a right triangle if we know the lengths of the other 2 sides. Let's meet a famous Pythagorean triplet 3, 4, and 5. These numbers are the best of friends because they satisfy the Pythagorean theorem. Let's test it out. If we plug in a equals sine 3, b equals sine 4, and c equals sine 5 into the equation, a squared plus b squared equals sine c squared, we get 3 squared plus 4 squared equals 5 squared, 9 plus 16 equals 25, 25 equals 25. See, the equation holds true. This means 3, 4, and 5 are indeed Pythagorean triplets. But wait, there are more triplets out there. Many other sets of numbers satisfy the Pythagorean theorem. For example, 5, 12, 13, 8, 15, 17, and so on. Some Pythagorean triplets are extra special. We call them primitive triplets. These triplets have no common factors other than 1. Think of them as the original recipe. They are the most basic form of a Pythagorean triplet. One example of a primitive triplet is 5, 12, and 13. Let's check if they follow the Pythagorean theorem. 5 squared plus 12 squared equals 13 squared. 25 plus 144 equals 169. 169 equals 169. Yes, they fit perfectly. Since 5, 12, and 13 have no common factors other than 1, they are a primitive Pythagorean triplet. Section 5. Non-primitive triplets. Scaling up the fun. Now let's talk about non-primitive triplets. These triplets are like scaled-up versions of the original recipe. They are formed by multiplying each number in a primitive triplet by the same whole number, other than 1. For example, if we take our trusty primitive triplet 3, 4, 5, and multiply each number by 2, we get 6, 8, and 10. Guess what? This new set of numbers is also a Pythagorean triplet. 6 squared plus 8 squared equals 10 squared. 36 plus 64 equals 100. 100 equals 100. See? We can create many non-primitive triplets by scaling up primitive triplets. Section 6. Baking up triplets, Euclid's formula and more. Mathematicians are like bakers. They have special formulas to generate Pythagorean triplets. One famous formula is Euclid's formula. It states that for any pair of integers m and n, where m is greater than n, we can generate a Pythagorean triplet using these equations. A equals m squared minus n squared, b equals 2mn, and c equals m squared plus n squared. Another fun way to generate triplets is using the odd number shortcut. Pick any odd number greater than 1. This is your a. Square a and divide it by 2. Round the result up to the nearest whole number. This is your b. Round the result down to the nearest whole number. This is your c. These methods allow us to create endless Pythagorean triplets. Section 7. Triplets in the real world, from buildings to games. Pythagorean triplets are not just for math books. They have real-world applications too. Builders use them in construction to ensure buildings are square and stable. They use the 3-4-5 triplet to check for right angles when laying foundations and framing walls. Game developers use Pythagorean triplets to design levels and calculate distances in video games. You'll find them in computer graphics, navigation systems, and even in space exploration. Section 8. Test your triplet trivia. Ready to test your Pythagorean triplet knowledge? Try these questions. Is the set 7, 24, 25 a Pythagorean triplet? What is the name for a Pythagorean triplet with no common factors other than 1? Can you generate a Pythagorean triplet using Euclid's formula with m equals 4 and n equals 2? Learning about Pythagorean triplets is a great adventure in the world of numbers. Keep exploring, keep questioning, and keep the magic of math alive.